In this week's video, we're going to be taking a look at React. The goal for this video is to make sure that we're going to be covering the most fundamental concepts that you need to know within the React library so that you can start building some really cool and snazzy front-end applications using the React library. So we've got quite a lot to cover, so let's get into it. So one of the first important things that we should probably talk about when it comes to React is the fact that React makes our lives as UI developers quite a lot easier by the fact that it actually offers us what's known as the virtual DOM. So if you kind of think about what the DOM actually is, right? In the browser, you have this thing called the DOM, which basically stands for the Document Object Model. And all this really is, it's nothing more than a sort of tree-like structure that represents how things are kind of getting rendered on your screen, right? So each one of your HTML elements are really nothing more than sort of nodes within this tree-like structure. So the virtual DOM is basically going to be an in-memory representation of the sort of actual DOM. It's now us as React developers, when we're actually writing our React code, we're actually going to be developing against the virtual DOM and not against the real DOM. And the reason why this is now going to be very beneficial to us as developers is because it's now going to be the responsibility of React to kind of take your changes that you have actually implemented and sort of affected on this virtual DOM and make sure that those changes actually go ahead and get applied to the real DOM. And so that means is that the actual logic of rendering things on screen is now going to be the responsibility of React and not the responsibility of the developer, which means I don't have to, as a developer, worry about how things are going to get rendered on screen. I can simply say, this is what I want my screen to look like. You React, I want you to figure that out for me. Now, another thing that React actually offers us, which of course makes our lives tremendously easier when it comes to writing nice UI applications, is the fact that we get to build our applications using the component model. So for example, take the actual built-in HTML element, the input that exists within the browser, right? So we have an input, we've used it in just about every application we've ever written, right? But if you think about how much logic and actual work the input itself is actually doing, right? It can keep track of the data that you're kind of typing in right now. It has the on blur event, the on focus event, it has the on input event. There's just so much logic and so much work that the input is actually handling for us sort of under the covers. But the cool thing is for us as developers, we just get access to all that sort of goodness that the input is giving us by simply just using the HTML input tag. And we can use it again and again as many times as we want. And we don't have to actually go ahead and keep re-implementing the actual underlying logic because it's all just there sort of encapsulated within the sort of fact we have the input tag. Now imagine being able to have the same exact goodness, but for our own sort of custom built components or for our own sort of custom built elements. And that's exactly what the component model basically says we can do. Essentially, we can go ahead and create a function, a sort of self-contained module that's going to specify all the necessary logic for a given element within the browser, basically what it's going to look like, the kind of logic that it's going to be handling, the styling of it, all that sort of stuff is all sort of self-contained, and then we can go reference it by its tag name or by its component name more accurately, and then we can just go use it throughout our application as we so choose to. That's basically the component model that React offers to us, and it makes our lives as UI developers much, much easier. So that's kind of some of the theory that I think we need to talk about before we start to actually dive into code. But now once we have that out of the way, let's actually go ahead and bootstrap a new React application using the Create React App tool, and then we can actually start playing around with some of these concepts and seeing the code firsthand. So let's do that now. Okay, so now you can see that I'm in my terminal, and what I'm writing is I'm saying npx, I'm calling upon the npx tool, and I'm telling it to use the Create React App tool. So the Create React App tool is essentially a tool that is offered to us that allows us to go ahead and bootstrap new React applications without having to worry about any of the configuration. So essentially, React really does have a reliance on Webpack, it has a reliance on Babel, and a lot of other kind of configuration that you need to take to be able to start writing React. Now the cool thing is, using this tool, Create React App, we can just run one command from within our command line, and within a few minutes, and actually just a minute really, we can already have a fully bootstrapped React application that we can kind of start using and playing around with it. So the way that it gets used is we can use the npx tool to tell it to call the Create React App tool, and then following the sort of Create React App command, we will then pass the name of the folder that we want to call our project. So in this case, I'm basically just building a simple playground so we can start looking at some of these concepts through code. So that's why I'm naming it Playground, but now if I hit enter, I'm going to get a new folder called Playground, which is going to be our React application that was bootstrapped for us using this create React App command line tool. So I'm going to hit enter and let that run, and I'll come back once this is done. Okay, so one overheating Mac later, we now actually have our React project done, and as you can see, I can now cd into the playground folder, and then I can go ahead and just run the application by running yarn start. So let's do that and see what happens. Okay, so I've cd'd into the playground folder. Now let's go ahead and run the command yarn start. And let's of course see what happens. So now, as you can see in the terminal, the project is now running on localhost 3000. So if I go on into my browser and I go on over to localhost 3000, we can now see that we get this kind of spinning logo, which is an SVG, and then it says edit source app.js, save and reload, and then of course we can click on this link to go ahead and learn a little bit more about React. And once again, all this kind of comes within the boilerplate code that has been sort of bootstrapped for us by this Create React App tool. So now let's actually go ahead and take a look at this folder that we just created and see what was actually given to us and start talking about some of the concepts within React. React. Okay, so here I am now in my VS Code folder. I've opened up the Playground project inside of my VS Code. So let's go and take a look at the index.js file first. The index.js file is going to be the sort of first file that actually gets executed when we run the yarn start command, or npm start. Essentially, this is where the sort of bootstrapping of the application basically happens. So one of the first things that I'm going to want you to take notice of on this file is that here on line 4, I'm importing something called app from a local file called ./app. And so we're not going to get into this too much just yet, but suffice it to say for just now, this is actually going to be the sort of first example of a component that has already been built for us by the sort of Create React App tool. But more importantly, the thing that I really want to draw your attention to is kind of what's happening between lines 7 and 12. So you can see here on line 7, we're basically calling upon the sort of React DOM library that's been installed for us. So again, we actually install React, and then we also install React DOM. Now, granted, this has actually been installed for us by the Create React App tool, but nonetheless, both of these separate libraries are actually going to be installed. Now, 90% of the time, in fact, I should probably even say 99% of the time, you're going to be dealing with React itself, not React DOM, but all that sort of dealing with React, which basically means you're dealing in this sort of virtual DOM land, will mean nothing unless if you actually use something like React DOM to actually go ahead and take your code and then inject it into the actual DOM. And so that's exactly what's happening right over here. We're basically calling upon the React DOM library, calling upon its render method, and we're telling it to kind of take this app component that we have now imported from our local file ./app, which we're in just a moment going to see what's actually within that file. But for now, we're basically saying, go and find me an element that's going to have an ID of root, take whatever is inside of this app component and inject it inside of that actual element. Now, what's going to be interesting for you to notice is that we actually move back on over to our file structure and we go into the public folder. We actually have a real HTML file that lives right over here inside of the public folder, and down here inside of the body, we can actually see that we do in fact have a div. It's currently an empty div, but this div does in fact have an ID of root. Now, if you notice when we previously ran this app, the app itself, the body of the app was certainly not empty. We have this sort of spinny logo, we had some words, we had a link, so it's clearly not empty. And that's exactly the point. The HTML right now, sort of before the application runs, is nothing more than a basic empty file. But once the actual application runs and the JavaScript starts to get executed, now React is basically starting to take over. And so right here, React DOM is basically taking our sort of virtual DOM, our sort of in-memory representation of the DOM, and then the real DOM, and then kind of bridging the gap. And that's happening here because we're calling React DOM.render. So now let's actually take a peek at what's actually going on inside of our app component. So here we are now inside of our app.js file. And one of the first things that I want you to kind of take notice of is you'll see here that we're creating this function and we're calling this function app. But interestingly, you might of course be used to that whenever you're kind of naming your functions in JavaScript, you're typically going to have the first letter of the name be lowercase. But in this case, you're going to notice that it's actually an uppercase A. And so the reason why this is because basically we're trying to sort of denote that this is no ordinary function, but instead this is actually a React functional component. Essentially, it's going to be a component within React. And the way that we denote that is by the fact that this function name actually has an uppercase letter for the first letter. Now, the next most important thing that we should probably talk about right here within this file is this sort of HTML looking syntax. Now, the reason why I call this HTML looking syntax is because, as it turns out, it's not really HTML. Actually, it's JavaScript, and more specifically, we call this JSX. Now, what exactly is JSX? So it turns out when you're actually writing React, at no given point in time you ever writing HTML. The only HTML that really exists within a React project is going to be inside of the index.html file, which is going to be right over here. Otherwise, all of your code that you're writing is really always going to be JavaScript. So that means that even when you're actually trying to build up like a div or a header or an image or whatever, you're really going to be using the React API, the React sort of JavaScript API to kind of build up those actual elements. And as it turns out, React actually has a sort of primitive version of how you can actually write that code. Let me show you that really quickly. So as you can see, for example, here on line 4, I've now written React.createElement passing in the span. Essentially, if I would now want to go ahead and actually create a span, this would basically be the actual underlying syntax that I can really use within React to go ahead and actually build a span. Because again, in React, we don't write HTML, we're always just writing JavaScript. But of course, the problem is this kind of syntax would become cumbersome very, very quickly. So what React now offers us is this thing called JSX, which looks a lot like HTML to make it very familiar to most web developers who have already been writing some kind of HTML for any given amount of time. But the cool thing is it's not actually HTML, it's really just JavaScript. And the way that we can actually tell that this is just JavaScript is because you'll now notice that here, when we're trying to sort of apply a class name to our elements, typically if you're writing regular HTML, when you're trying to apply a class name, you just use the word class or the attribute class. But because this is JavaScript and class is a reserved keyword within JavaScript, we can't just simply say class. Therefore, we actually have to go ahead and write class name. And we're going to, as we start to dig through some of the sort of fundamental concepts that we're going to be talking about in this video, we're going to see a few more ramifications of the fact that JSX is not actually HTML, but it really is just JavaScript. And that's going to come up soon. Okay, so now let's try to actually build something rather small with React. Essentially, let's imagine that we basically have a button, and every single time we click on that button, we're going to have some kind of number that's going to keep incrementing by 1 as we go and click on that button. So let's see what that looks like in React terms. Okay, so as you can see right now, based on the code that I'm writing, what I'm attempting to do is I'm attempting to define a variable called counter whose initial value is going to be equal to 1. I then have an h1 that's going to actually render the value of counter, and then I have a button, and then button basically is going to have an on-click event handler that's going to get specified on it. And then what this on-click event handler is going to do is that every single time I actually go ahead and click on the button, the event of click is going to get raised, and in response to that event, we're basically going to be calling this anonymous function that I've passed in right over here, and we're going to attempt to increment the value of counter by 1. So let's see if this naive approach of actually trying to do this type of application within React is going to work. Okay, so here we can see that so far things are working a-okay. We've got the number 1 kind of getting rendered on screen. Now let's actually go ahead and click the button, but that didn't work. That didn't work at all. So the reason why this didn't actually work is because in React, whenever you actually want to go and update your UI, you have to use a special mechanism to make that happen. And this mechanism is basically called state. So let me actually start writing a little bit more code using this new mechanism called state, and then we'll start to take a look at what the code looks like, and all this is going to start making a little bit more sense. So let me do that now. Okay, so here are the changes that I've made so far. Here on line 1, you'll now notice that I'm importing something called useState from React. Now useState is basically what we call a hook. Hooks are essentially building blocks that React offers us to kind of make it possible for us to kind of do our job. So for example, previously we just saw that if I was just trying to have a basic counter, just set let counter is equal to 1, if I want to go ahead and update that counter, my UI wasn't actually changing. We have to actually use one of the sort of mechanisms that React actually offers us to make that possible. And hooks are some of these mechanisms that React offers us to make our job possible. So in this case, we're using the sort of useState hook, and this is going to be the mechanism that we can use to actually go ahead and cause a UI change to happen at the response of a sort of button click or some kind of state change. So basically what we're doing here is we're pretty much going to be calling this useState function, passing in a sort of initial value that we're going to be setting to 0. And then what we're going to be getting in return for calling this function is going to be an array that's going to have 2 elements. So using array destructuring, what we're going to do is we're going to say that the 0th element is going to be the variable that's going to be set to 0. So in other words, this counter variable here is going to start out at 0 because that's what we kind of passed into the useState hook. That's going to be its initial value. And then the next argument to get with the sort of index 1 element is going to be the sort of updater function. So essentially the flow basically is like this. We're now going to go ahead and create a new variable called counter. We're then going to have the sort of corresponding updater function, which we're going to call setCounter. Now the key point here is this is now not just some kind of willy-nilly variable that we have just created ourselves. This is now a variable that we have declared using the sort of mechanism that React gave to us, which means React is now aware of this particular variable. Now the reason why this is now so important is because as we go ahead and change the value of this particular variable that React is now aware of, and we're going to from henceforth start referring to this particular variable as state, because that's essentially what it is. So React is going to be aware of our state, and as we sort of change the value of our state, React is going to say, oh cool, you've changed the value of state, let me go ahead and cause another render, let me start actually showing the new value in the UI. And so the way that this is now going to work is we're going to in our h1 render out the value of what counter is currently equal to. So now instead of simply just saying in the onClick that counter is going to be equal to plus equals 1, rather what we're now going to do is we're going to be using the updater function that was applied to us by this useState hook, and then with this updater function, we're now going to go ahead and update the value of counter, and therefore causing another render to happen on screen. And now we're actually going to start to be able to see the sort of number get updated as we click on the button. So let's see if all this actually works. So now if we come on back to the browser, we can see that it is successfully rendering out the 0, which was in fact the sort of initial value that we supplied to the useState hook. Now if we go ahead and click on the button, with each click we can actually see that the number is in fact incrementing. And again, the reason why this is because now we're not just using any variable, but we're actually using a state variable, which means this is now a variable that React is aware of. And essentially what React basically says, if you want your UI to update, you're going to be basically doing that through data, which leads me to one of the most important mindset shifts that you need to start having whenever you're a React developer. You might be used to sometimes whenever you want to kind of cause UI changes to actually go and do those UI changes yourself. In the terms of React, when you're a React developer, you can kind of think of yourself as less of a UI developer and more of a kind of data developer. Now the reason why I say that is because any single time that you want to go ahead and affect a new change within the UI, you don't have to think about it in UI terms, you have to think about it in sort of data terms. In this case, I'm basically saying, if I want my UI to change, if I want the number on screen to change, I need to change the value of what that number actually is. So basically, if we come back into code, the reason why this is actually changing is the reason why the UI is actually getting re-rendered and the number is getting reflected on screen with its sort of new value is because we're basically saying that we're going to be calling this particular updater function. Again, this is the updater function that was given to us by state, and we're going to go ahead and pass in a new value to it. So we're basically saying that we're going to, so as it turns out, this updater function can actually receive a function as an argument itself. And so this function that is getting, that the setCounter function itself receives, the first argument argument that function get is going to be the sort of current value of state. So in other words, on the initial render, it'd just be equal to 0. And then we're saying n plus 1 and then you know, n plus 2 and then so on and so forth, right? Like that type of thing. We're just going to keep incrementing. And because we're now basically updating the value of this particular variable here in state, now React says, okay, I'm going to go ahead and re-render and reflect those new changes on the screen. So again, if you want to update the UI, you got to update the sort of corresponding bit of data to kind of have the UI reflect the new state changes. And I know if this doesn't make much sense just yet, it's going to start to make more sense as I kind of show you a few other examples in the sort of same vein. So now I actually have a bit of a different example. So here's basically what I'm doing. I'm once again using the useState hook, only this time instead of passing in a number, I'm actually passing in a string. And so in this case, the value of that string is going to be Chaim. Here I've got a variable called name, which is going to get initialized to this initial value here of Chaim. And then I have the corresponding updater function, which I've called setName, and that's going to be the sort of function that I'm going to have to use if I want to actually update the value of name and therefore cause another render or sort of another state change to happen within the UI. And then basically what I'm doing is here I have an input specified, and I'm saying that the value of the input is going to be equal to name. Now I want to kind of show you something very interesting that's happening that's going to once again help you kind of understand the sort of concept that if you want to update the UI, you got to do that through state. So here, as you can now see, when I go back to my browser, you can see that I've got an input, and the input does in fact say the word Chaim within it. But crucially, if I now try to type into this input, and I don't know if you can hear that, but I'm trying to type right now, but nothing's actually happening. And the reason is because the value of state right now, the value of name that is being bound to the input. In other words, I've said that the value of input, right here, I've said the value of input is going to be equal to name. The problem is I'm not actually changing the value of name. And since I'm not actually changing the value of name, the UI is not actually re-rendering. And since the UI is not actually re-rendering, the browser is not reflecting those changes within the input. So despite the fact that I'm typing, but since the React is never re-rendering my component, so those new UI changes are never getting committed to the real DOM, we can't see that. So again, the way to solve this is we have to actually go ahead and change the value of name. And if we change the value of name, now we're going to go ahead and cause another render. And now this sort of subsequent render is actually going to reflect our actual state change. So let me show you that now. Okay, so the only thing that I've really added right now is I've gone ahead and specified the onChange event to the input. So you can kind of think of the onChange event kind of like the onInput event in sort of standard HTML land. Basically, all this is just going to be an input that's going to get fired in sort of every sort of keystroke. In other words, every single time that you're typing and the input value is actually changing, you're going to go ahead and get this onChange event to get called. But crucially, the most important thing that we're doing now is we're actually using the updater function that was applied to us by this useState hook, and we're saying setName, pass in eta target the value. So whatever you're currently typing in, pass it into setName, which is then going to subsequently go ahead and update the value of name. That's going to then cause another render, and now this new render is going to go ahead and reflect the actual new data that we've just updated, and we're going to now see our input actually change. So if we come back into the browser, as I now type, we can see that whatever I'm typing to the input is in fact getting reflected within the browser. So once again, if you want to update the UI, you got to kind of do that through state. That's the sort of main mindset shift that you need to have when you're a React developer. Updating the UI requires you updating the data. So one of the other really common hooks that we're going to be using, and again, hooks are basically just building blocks that React kind of gives us to make it possible for us to do our jobs. One of the other very common hooks that we're going to be using is something called useEffect. So let's take a look at how useEffect works and some of the things that we can do with it. So before we actually even take a look at the code, let's just talk about a little bit of theory in terms of useEffect. Say you have a use case where basically as soon as the page actually loads, you want to actually go ahead and fire off a request. Turns out useEffect is actually the kind of place to do this. So if you kind of think back to sort of functional programming concepts, if you basically have a function that you're trying to keep pure. So a pure function is basically a function that given the same input, you always get back the same output, meaning it has no side effects. It doesn't actually mutate the state. And also it doesn't actually do any effects. There's no console logs. There's no talking to the file system, no talking to the database, no making AJAX requests. That's basically what makes a function functional if it doesn't sort of violate those rules. Now, basically React tries to kind of enforce some kind of functional behaviors whenever we're trying to program with the React library. So one of the things that we now need to do is we do in fact have to have a place to kind of make our AJAX requests. Like I just said, imagine the use case where you're like on a page load, and now you want to go ahead and say that as soon as this page loads, you want to kind of make a request to kind of get that initial data for this page load. So basically React says the place to do that is going to be in this useEffect hook, and you can kind of denote based on the fact that it's called effect. Essentially, this is where they kind of want you to do your side effects. So here what I'm now doing is I'm basically specifying this useEffect hook. useEffect hook is going to be a function that's going to be receiving a function as an argument. So here you can see I'm basically specifying a function that I'm passing into useEffect, and all that this function is really doing right now, it's a very simple side effect, but it is a side effect nonetheless. I'm basically doing console.log. Now that's not to say that this is the only place in which you're allowed to do a console log. I'm not saying that whatsoever, but I'm simply trying to show you an example of using useEffect and also trying to show you some examples of when useEffect actually runs. So in this case, if I now go ahead and run this application, let's see when we do in fact actually get this console log. Okay, so first of all, you'll now notice that as soon as I actually went ahead and refreshed my browser, we can already see they do in fact useEffect get the console log of here, which means that the useEffect already ran once. But also, interestingly enough, now as I start typing into this input and the component keeps re-rendering again and again, which you can see based on the fact that the input is actually updating. So again, the input is updating, which means that the component is in fact re-rendering. We can see that the console log here is happening again and again, which means that the useEffect is running both after the initial render and then all subsequent renders after that it's also running again. It turns out though that we can actually have some fine-grained control over when this useEffect actually runs. And let me show you how we can do that. So aside from the actual first argument that gets passed into useEffect, which is basically going to be a function, the second argument that useEffect takes is actually going to be an array. So if let's say I want to tell useEffect I want you to run once and only once, because by default, and this is something that we cannot control, useEffect will always run once after the sort of initial render. That basically means the component gets sort of created for the first time. It goes through its first render of committing whatever the sort of initial JSX is on screen with all the initial data. After that's done, we now say that this component has mounted. So in other words, that's kind of like the did mount phase. The component is now mounted on screen. And after that first time that the component did mount, the useEffect hook is always going to run no matter what we do. But if say we don't want it to kind of run all other times, let's say we don't want it to run on every single keystroke or every single time the component re-renders. Let's say we just actually want it to run just that sort of one time. So the way that we can actually do this is by passing into sort of the second argument, which is an array. We can just kind of keep it an empty array. By passing in an empty array, we can basically tell useEffect I want you to run once and then only once, never again. Now let me actually demonstrate that. So now if I actually come back into the browser and then I refresh my browser, you can now see that we do in fact get this one console log here. But then if I go back into my input and I start typing, causing the component to re-render again and again, you'll see that we're not actually getting more console logs because we've effectively told this sort of useEffect hook run the one time and only that one time. And the way that we told it that is using the sort of empty array. Now, of course, I know you're wondering, why are we using an array and why does the array have to be empty? Like, this is a very weird syntax to kind of tell useEffect to run once and only once. So let me explain. Okay, so if you look at the code that we have right now on screen, you'll now notice that I actually have two bits of state that this component is actually defining. And that's, by the way, something that you should also be aware of. You can define as many different bits of state as you want within a particular component. So your state can be a sort of complex object that has all of your state nested in just one object, or you can have a bunch of different small variables to kind of keep track each one of a small subset of your state. You can do that however you want. That's totally up to you. So in this case, we're now keeping track of two bits of state within this component. One is going to basically be keeping track of the name, and then the other one is going to be keeping track of the sort of counter. Now, what I would like to do is I basically want to now tell my useEffect I want you to run only when the counter changes, but not when the name changes. And so now that's where the sort of dependency array, this sort of second argument that we're passing to the useEffect, really starts to shine. So now by actually passing the counter variable that we have right over here into the dependency array of the useEffect, basically what I'm now telling the useEffect is I want you to run. Now you're going to run after the first render. There's nothing that I can do about that. But in all sort of subsequent renders, I only want you to run. I only want you to actually go and execute the code within yourself if the counter variable changes, but not if the name variable changes. And the way that I'm doing that is by actually taking the counter variable and passing it into the dependency array. So now if we actually go back to the browser and actually refresh the browser, so of course we're going to get that sort of first initial here. And now as I start typing into the input, we actually see that the useEffect is not running because what I'm actually updating is the name variable, not the counter variable. But on the other hand, if I actually click on this button and start updating the value of the counter, we do in fact see that the useEffect is running again because I've explicitly told it I want you to look at the counter variable, and if that changes, go ahead and re-render, which is why we actually have the sort of funky syntax of having the array as a second argument to useEffect. And that is also going to be the way that we can tell the useEffect, you know what, I only want you to run once and never again. And the way that we do that is by passing nothing into the array. We simply leave it an empty array. So one of the things that we still haven't really taken a look at through all of our exercises is the fact that React actually offers us a component model. So we haven't really gone and built another component, right? Because essentially one of the things that's so cool about having the component model is we can actually modularize our code. So if you're kind of thinking about, you know, putting sort of UI development aside for just a second, right? Say you have like a pretty big project and then you have a kind of unit of work, some kind of work that kind of needs to happen in more than one place throughout your application. So what you're going to do is you're going to take that code and kind of put it into its own function. So now all of that logic is encapsulated and sort of held within that function. And now wherever you kind of need that work to happen, you just call it based on its function. Well, now we can actually do the exact same thing using components. So let's actually take a look at doing just that. So here you can now see that in this sort of very same app.js file, I've now gone ahead and I've defined a new component. And basically I'm calling this component display counter. And you can tell that it's a component because the uppercase D is sitting in front of the name. Basically the first letter of the name has actually been capitalized, in which that basically means that this is actually going to be a component and not just kind of any other function. Now, one of the other things that you should already take notice of right away is the fact that this function, or this component rather, is actually receiving something called props as an argument. Now, the fact that this is called props is actually not by accident, but rather this is by convention. So what's happening is here, you can now see that our app component is actually going to be sort of using the display counter component. And once again, we can just use this just as if we'd be writing any kind of regular JSX. The only difference is when we're basically using a sort of built-in JSX element that kind of tries to resemble resemble a real-life HTML element, we use a sort of lowercase syntax. But when we're using a component, whether it's a component that we ourselves have built or we're consuming it from some kind of library that we've installed, but essentially when you're using a component and not a sort of underlying element, you actually use the uppercase letter. So just like the name of the function is actually uppercase, so too when we use it, it also has to be uppercase. But now basically what this now shows us is that essentially a sort of parent can go ahead and render another component as a child. So the relationship here now between app and display counter is that app is now the parent of display counter. Now the thing is, you can see that the counter, the whole goal of the counter is that we want the counter to be responsible for simply displaying the actual value of the counter on screen. But the thing is, we have to actually make sure that the counter variable is accessible to the sort of display counter component. And the way that we do this is by props. So essentially props is nothing more than a vehicle by which we can actually take data from one component and pass it down to another component. The only constraint that exists, which basically dictates whether or not we can actually go ahead and pass some kind of data from one component down to another component, is the fact that the component that's actually doing the passing, the component that's actually sending the data downwards, must be higher in the hierarchy than the sort of component that's receiving the data. So essentially you have to either be at the minimum a parent. You can of course be higher than that. You can be a parent or a grandparent or a great grandparent. It doesn't really make a difference. But at the minimum you have to be at least one level up above the component to which you're kind of sending it down. If you're simply two siblings, like in this case, if you basically look at this button here and this input, they're basically sitting side by side. They're essentially siblings. So they wouldn't technically, if they were components, in this case they're not even components, but let's say they were, they wouldn't be able to basically send props to one another because they're actually siblings. But in this case, the app component is basically the one rendering the display counter component, which makes it its parent. Therefore, the app components can now actually go ahead and send down props, which again is nothing more than a vehicle by which we can send data from one component down to another component. So here we're basically saying that this function here, or rather this component, is going to be receiving props as an argument, and then off of this props, we're basically saying that we're making an assumption that props is going to be an object, and that's actually going to be always true. Props will always be an object, but the assumption that we're making is the fact that we're going to have a key on this particular object called counter that's going to be the very counter that we're trying to display. And so in order to ensure that we actually meet that sort of contract, when we actually go ahead and render the display counter component, we actually have to go ahead and pass that prop down to the display counter. So the way that we do this is as following. So here you can now see we're actually saying that we're going to be passing down something called counter. Now I could have easily named this whatever I want. This could just as easily be called foo as well. In other words, whatever's on the left hand side of the equal sign is basically whatever I decide to name it, and that could be anything. But then whatever's on the right hand side of the equal sign have to actually match the variable that I'm trying to pass down. So in this case, because I'm actually trying to pass down the counter variable, so here I'm basically saying there's going to be a prop which we're going to be calling counter. And the reason why I can over here say props.counter is because that's what I called it here on the left hand side of the equal sign. And then what I'm passing down is going to be the actual counter variable right over here that I have in state. And now I can simply say that within my h1, go ahead and render props.counter. And now every single time the actual counter value is going to get updated, we're going to go through another render cycle. The display counter component is also going to render and reflect that sort of new number that we have now in state. It's going to now reflect it on screen. So let's take a look. Okay, so now you can actually see that the counter is being displayed. It starts at 0, and then as I click, the counter does in fact get updated. And again, this is happening because we have the app component taking the value of what counter is, and it's passing down as props to the sort of child component. That's its only job for the child right now is to just actually go ahead and display the data. So now the last thing that we're going to actually take a look at in this particular video in terms of React fundamental concepts is going to be what happens when we actually have a collection of data and we want to kind of loop through that collection of data, and for each item within that array or within that collection, display one element on the screen. How would that work? So here now on screen, you can basically see that I've went ahead and I've used the useState hook to go ahead and specify that we're going to have this array called numbers that's going to be initialized to this array that's going to have the numbers 1, 2, 3, 4, and 5. I did actually specify the set numbers function now, but I'm actually not going to be using it for this example. But now when we actually come on down to our JSX, you'll now notice that here, when I'm trying to loop over my numbers array, I can simply use a sort of built-in JavaScript.map method. Now again, the reason why I can do this is because this isn't actually HTML. Had this have been HTML, I would have to use some kind of template language like a v-4 that Vue offers, or the ng shenanigans that Angular offers. But the point is, those are all sort of template language syntax, and the reason why that is because you're basically doing the looping logic inside of your actual HTML. Here, this isn't actually HTML, this is actually JavaScript, which means I can use real JavaScript syntax. So I can really very simply say numbers.map, and a map is a very sort of common method that we use in JavaScript all the time to kind of loop through an array. So what I now am going to do is I'm going to say that I'm going to use the map method to iterate over my numbers array. For every single iteration, or for every single element within that array, we're going to go ahead and call the render number function, which has basically been specified right up over here. That render number function is really nothing more than a function that's a callback to the map function. And as you already probably know, that the sort of callback function that you pass passed to a map, the first argument that it receives is going to be the element at that iteration. The second argument that it receives is going to be index of that element. So here you can see I've got the n for the actual number, the I for the index, and then all I'm very simply doing is I'm going ahead and I'm rendering an h1 that's going to actually specify the n within the number. Now you'll also notice that we've got this one additional thing here. We're basically saying key is equal to I. Now I'm not going to be covering this too much in this video because it's kind of a more advanced topic and I'm going to be saving that for a different video, but suffice it to say this basically aids React in kind of going through its reconciliation process, which as you mentioned, which I kind of mentioned earlier, that when React kind of wants to start rendering things on screen, it kind of goes through this big algorithm to kind of figure out what's different between now and the sort of last iteration or the sort of last render, and that's kind of called the reconciliation algorithm. And so when it comes to dealing with sort of collections of data, we basically need to supply the key to kind of help React go through its reconciliation algorithm, because essentially React doesn't want to have to kind of look at the data to keep track of whether the data is different. React can basically just look at the key to see if the key is actually different. If it's the same key as it was in the last render, that means I can leave this element alone, don't need to render it. But if the actual key is different, that means that regardless of whether or not the data is different, but so long as the key is actually different, that means that you want me to go ahead and render this again. I should also point out, as far as the actual React documentation itself is concerned, using the index as a key is not recommended. Ideally, what you really want to use is some kind of like unique identifier, like let's say an ID that you get from like your database, or a GUID or an UID or something like that is sort of more recommended. But for the sake of this example, just to kind of see how we can actually loop over an array of items and then for each item just render something, I do in fact just want to supply a key just to kind of make you aware that by default you always want to make sure that whenever you're rendering some kind of collection within React, you always want to make sure that you're supplying a key, and the value that you supply to that key should always be unique. So in a pinch, the index works, but that's not actually recommended based on the React documentation. And again, in a future video, I'll cover this whole topic in way more in depth because it's kind of an advanced React topic. So now if we actually come on back to the browser, we can actually see that we do in fact have each one of these elements getting rendered. We got the 1, the 2, the 3, and the 4, the 5. So essentially, we've been able to successfully iterate over a collection of items within our React code, and then for each item within that array, go ahead and render some kind of element. In this case, we're basically rendering an h1. So these are all the concepts that I kind of want to cover in this video, and I do hope that you kind of were pretty clear with these concepts, because next week what we're going to be doing is we're actually going to be taking these concepts and building a somewhat more real-life example using React. So basically, we're going to be building a simple application that's actually going to be consuming the GitHub API, and we're going to be basing that entire application off of what we just learned within this particular video. So I hope you enjoyed this video. I hope you found it useful. If you did, please drop a like, subscribe, and I'll see you next week in another video. Woo!